Okay, the last little bit in the parametric equations chapter is modelling with parametrics. This is before we look at officially differentiating and integrating with parametric equations, which will be done in future videos. But we might need to find minimum, maxima of x and y for this video. And it's essentially just what we've been looking at with parametric equation definitions, but it's got some kind of scenario with it. And these kind of questions can come up in examinations. So let's have a look at a couple of these. I've got two. So we've got a parametric definition here. X equals 2 sine 24t minus 1, and y equals 4 cos 8t plus pi on 4, and we're told t goes between 0 and 2 pi. An ice skater's motion is modelled using the parametric equations above. So here we've got a sketch of the curve, and this is the path that an ice skater is going to take on an ice rink. And we're told that t is measured in minutes. For part A of the question, nice simple part to get us started into the question, is to state the initial location of the ice skater. Now the initial location is just going to be the first t value. Now in this case, t starts at 0, and that's usually what happens for the initial. So what we can do is we can just plug in t as 0. So 2 times sine of 0 is 0 minus 1. So the answer to part A, the x-coordinate is going to be minus 1. And if we plug in t as 0 here, we're going to get 4 times the cosine of pi on 4. Now, cosine of pi on 4 is root 2 on 2. So if I times that by 4, that is 2 root 2. Okay, and that's positive. So if we're going to look at the sketch, it looks like the ice skater is starting about here. Now, as t increases, x will increase and y will decrease. So we are going that way around because that is the direction from the starting point where x increases and t decreases. Okay, not that we need to know that, but just an interesting point to pay attention to. Okay, part B. Find the coordinates of the points where the ice skater crosses the x-axis. Okay, so there are 2 points where the ice skater is going to cross the x-axis, and that is here and here. So we're going to find these 2 points. I'm going to label them x1 and x2. So to find where any curve crosses the x-axis, we're going to set y to be 0. That is the equation of the x-axis. So we're going to set that to be true and solve. So we're going to get t values from solving y at 0. I'm going to plug those t values into our x. Okay. So we are solving the equation. 4 times the cosine of 8t plus pi on 4 is 0. Obviously the 4 is never 0, so the cosine of 8t plus pi on 4 is 0. And then I can inverse the cosine of that. So I get 8t plus pi on 4 is either pi on 2 or 3 pi on 2. And those are the only 2 values that we can take because those are the only 2 times that the cosine function is 0 between 0 and 2 pi. Actually saying that, it's t is between 0 and 2 pi, isn't it? So there may be other solutions. In fact, yes, there will be other solutions because the ice skater is going to go round this line a few times, so it's going to keep crossing these 2 points. But each of those is going to give one of those points. Okay, so let's look at pi on 2 first. If 8t plus pi on 4 equals pi on 2, then I can subtract pi on 4 and then divide by 8. So I get that t is pi on 32. Okay, so that's the first t value. I'm going to call it t1. And then it could be 3 pi on 2 as well. So I could do the same thing, except there's going to be a 3 on top here. So 3 pi on 2 subtract pi on 4 is 5 pi on 4. So it's going to be 5 pi on 32. Okay, so those are the 2 t values that make y 0. So to get my x values, I need to plug them back into the definition of x, which is up here at the start of the question. So my x value is going to be 2 times the sine of 24 subtract 1. So I'm going to get my calculator out for this. So 2 times the sine of, do that again, 2 times the sine of 24 times t1, which was pi on 32. That's root 2, so then subtract 1. So that's root 2 minus 1. And the other one is the same thing, but with t2 in it. So sine of 24 t2. And t2 was 5 pi. And we get negative root 2. And don't forget, of course, to subtract the minus 1 again. Okay, so these are my 2 x coordinates. So I can find then the coordinates then. So the answer to the question, this point here is going to be negative root 2 minus 1. And then 0. It's crossing the x-axis, so the y-coordinate is 0. And then the other coordinate over here was root 2 minus 1, 0. So positive root 2 minus 1. Just a note here, I called this x1 and x2, but actually the x1 and x2 are the wrong way around, just because I didn't know which one went with which at the time. So I should perhaps call that t2 x2, and then that's t1 x1. But it doesn't overly matter, because that's the answer to the question there. Okay, and finally, determine how long it takes the skater to complete one complete cycle and find how many cycles the skater does. Okay, so we're restricted for t values between 0 and 2 pi. So there's going to be a finite number of times that the ice skater is going to traverse this path. And we need to work out, first of all, how long it takes him to traverse the path once, and then how many times he traverses it altogether between the 0 and 2 pi. So to answer part C, let's start by considering how long it takes. So in the x direction, we've got a sine of 24t in there, which means that's going to repeat every 2 pi on 24 times, which is pi on 12. So we're going to have pi on 12, 2 pi on 12, which is pi on 6, 3 pi on 12, which is pi on 4, 4 pi on 12, which is pi on 3, and so on. So it's going to repeat quite a lot in the x direction, but that makes sense, because if you look at it in the x direction, it's kind of bouncing back and forth quite a lot for the one in the y direction. In the y direction, we've got a cosine of 8t. Now, obviously it's got a plus pi on 4 there, but all that does is phase shift it. It's not going to change the period. So just looking at the 8. So this is going to repeat every 2 pi on 8, which is pi on 4. So that's going to be pi on 4, pi on 2, 3 pi on 4, and pi, etc. So the smallest repeating number there is the pi on 4, because it's got to appear in both lists. So because that's the smallest number, that's the period. So pi on 4 is the period. So period equals pi on 4. So we can get our calculator out and say pi on 4 is 0.785, which is 47 seconds. So 47 seconds. So that's how long it takes the skater to complete one complete cycle. It's 47 seconds. And then the second part of this, part C, was how many cycles does the skater does altogether. Well, if it takes pi on 4 to do one cycle, and he's cycling around for 2 pi minutes, then, well, there's 8 of those in 2 pi. So pi on 4, pi on 2, 3 pi on 4, pi, and another 4. So the total is 8 cycles around. All right, so that answers that question. One more modelling with parametrics question. Okay. Two of the roads leaving a roundabout base at the origin connected to an estate in a loop as shown in the diagram. Okay, so we've got a roundabout here, and then these are going to be two roads, and it just forms one big loop around an estate. The curve is expressed by these parametric equations. Okay, so there's our definitions there, and we're told that t lies between 0 and 2. Part A of the question, find the value of t at the points P, Q and R. So P, I know it's not explicitly stated in the question, it would be in an examination question, but P is the maximum x value, Q is the maximum x value, and R is the maximum y value. Okay, so we're going to have to use some calculus, but we're going to use calculus on this. We're not going to use parametric differentiation. I've not done a video on that yet. That will come in a future video. What instead we're going to do is we are going to just look at when x is at a maximum and use that to decide what P and Q are. So x is this, which is a quartic. So I'm going to multiply it all out. So we're going to have 8t minus 4t squared into t squared minus 2t plus 1. And that's going to be minus 4t to the 4. And then I've got an 8t cubed plus an 8t cubed is 16t cubed. The t squared term, I'm going to have minus 16t squared minus 4t squared, so that's minus 20t squared. The linear term is just 8t, and there's no constant. And I've done that because I want to use calculus on this to find P and Q. So I'm going to call it x dot, which is the differential of x with respect to t, so dx by dt. So that's going to be minus 16t cubed plus 48t squared minus 40t plus 8. And I want this to equal 0, and that's going to give me t values for P at this point here, and then Q. Those are the extreme for x, aren't they? So that's going to be the turning points. So if I go into equation mode, I can plug in this cubic. It's a polynomial with degree 3. We've got minus 16 as the coefficient of the cubic, the 48 there, the minus 40 there, and the 8 there. In fact, they're all multiples of 8, so I could have simplified that. Okay, so I get t is going to be equal to 2 plus root 2 on 2, 1, and 2 minus root 2 on 2. Okay, fantastic. Now, if I take those t values and plug them back into the definition of x, I should hopefully get 1 twice and 0 once. So x let's go into computation mode. So let's have 2 plus root 2 on 2 and plug that into x, which is going to be 4 times my answer times 2 minus my answer times my answer minus 1 squared is 1, which is good. So x is so t equals 2 plus root 2 on 2, and x will equal 1 at that point. So that's good. So that's either P or Q. Don't know which one yet. Need to look at the y's. And if t equals 2 minus root 2 on 2, I suspect that's going to be the same thing because 1 lies in the middle of those. But we can check that by replacing this with a minus. And because I've used answer, it'll automatically recalculate, which is great. And then finally, I also got number 1, which I'm assuming will come out to be 0. Yes. So when t equals 1, which is the other solution I had to the cubic, x equals 0. But x is 0 is going to be at this point here, which I'm not actually interested in. So I could ignore that one. Okay, so let's get my y value so I know which one is P and which one is Q. So the y value can be calculated in a similar way to the x value, but using the y definition, which was the answer squared into 2 minus the answer. And the answer is going to start off as being 2 plus root 2 over 2. Okay, and I get 2 plus root 2 over 4. So 2 plus root 2 over 4. And I suspect it will be a negative for the other one. And it is. So that's 2 minus root 2 on 4. So this one is smaller than that in the y coordinate, and we can see that P is a smaller y coordinate than the Q, so we know which one is which. So at P, T equals this one, the smaller one, because the y value is smaller, so the T value is smaller. So that's 2 minus root 2 on 2. At Q, T equals 2 plus root 2 on 2. And then we'll come back to B in a minute. So that's P and Q. Now we can do something similar to find R, but R is a maximum of Y, so we're going to differentiate Y. So Y is 2t squared minus t cubed. So Y dot is going to be 4t minus 3t squared. If you want that to be 0, then either t is 0 or t is going to be 4/3. Yeah, makes sense. So we get to t is 2 minus root 2 on 2, then we get to t is 1, t is 4/3, and then we get to t is 2 plus root 2 on 2 before we get to t is 2 down the bottom. So I think all that makes sense, which is great. So t is 4/3. And then if we plug that back in, we'll be able to find the coordinates, which we're going to need for part B. So at R, t equals 4/3. And the t equals 0 is because actually this is a turning point. So this, if you were to carry it on past t into the negatives, it will start to go back up, or at least it'll be a stationary point. It might go back down if it's a stationary point of inflection. But so we got the 3t values for our points, and then we can use that to state our coordinates. So the coordinate of P, that was when t is 2 minus root 2 on 2, was x is 1 and y is 2 minus root 2 on 4. So that was P. The coordinate of Q, similarly, x is 1, this is Q up here, and y was 2 plus root 2 on 4. And the coordinates of R, well, we need to plug 4/3 in to our definitions of x and y. So let's do that very quickly, because I'm a little bit pushed for time right now. So 4 times my answer times 2 minus my answer times my answer minus 1 squared is 32 over 81 is my x coordinate. Yeah, so looks kind of like right. It's not quite halfway, is it? So halfway between 0 and 1 in the x direction. So kind of fits with the graph. So I'll go with it. I don't actually know the answer. So if I'm wrong, leave a comment. And I also need to work out the other one. So I delete all of that. Just replace it with answer squared into 2 minus answer. And that comes out as something much bigger than I expected. So I think I've gone wrong somewhere. Oh, there we go. It's 2 minus answer. There we go. 32 over 27. So 32 over 27. That's my coordinate for R. I knew that the first answer was wrong because it was 4 point something. And I know the sketch is not accurate, but it's clearly not 4 something in the y direction. So I knew it was wrong. So just having that little bit of sense to make sure your answers make sense before you commit to it makes it worthwhile. Okay, so that's it. Thank you for watching, and check out other videos on my channel. Thanks.